So this is about exponentials. There are some exponents here. First of all, write the problem down. There's no avoiding that. You gotta write the problem down. After that, you gotta try to figure out what to do to handle each part. Now, a calculator is allowed in the test. Now, can the calculator handle the y? No, but it could handle the 27. Because, I don't know if any of you know what 27 to the third is, but I don't. Judging by the noise of calculators being grabbed, most of you have one with you, which is awesome. Do you get that tomorrow? You really want one? I do not have calculators to give to people. I have like 2, and there's going to be like 5 people that don't have one because, happens. That means you're stuck without a calculator on a really hard test. Bad idea. If I were you, I'd put like a blue star on the back of my hand, so when I got home, I'd be like, why is there a blue star on the back of my hand? Oh, that's right. I better grab the calculator, stick it in my backpack. All right. So if I just do it with 27 to the third, just the plain third, 27 to the third, it's 19683. That's part of your answer. All right? But it's to the negative third. Then it's 1 over that, isn't it? And this y, it's got a power to a power, and then that's really not that hard. It's just 4 times 3 is 12, but it's negative 12th. You could put y to the negative 12th right here temporarily, because you can't leave negative exponents in your answer. That has to move and be down in the bottom as y to the positive 12th. Who would have had that one right? Nice. Okay. Next up, let's change to a completely different kind. Let's say that you had the cube root of 2x minus 1, and all of that is put to the fourth is equal to 3. Now you're trying to solve this thing. You're trying to get the x alone. I personally would probably have changed this whole thing. See if you can understand this. To 2x minus 1 to the power of 4/3, because that's what it is. That means that. The 4 is a normal power. Headphones need to come off your head. Okay, could you poke the kid behind you with the headphones on? Oh, there we go. Thank you. Okay, so back to, if I'm going to solve this, I would have started by just converting that weird-looking thing into this. Because then, all at once, I can put both sides to a power. What power would I want to put it to? The 3/4. And now, all of a sudden, I have 2x minus 1 equals, let me see what this decimal is. 3 to the, I'm using parentheses around my 3/4. 2.28 if I round it. And I just made a tragic mistake. Does anybody see it? It's not the rounding of the 2.28. You could round that to different places. Rosner? Salen? Yes, there's 2 answers. Good call, because you just square rooted, or in this case, fourth rooted. Any even root brings in the absolute values. Oh my gosh, is that going to be easy to miss? So easy that last hour when I was doing the practice problems, I missed it. I caught it at the end of the hour when one did a different problem, but I had done an even root and I had forgotten. Here's the problem I did in the other hour, just to show you another one that's like it. X to the 8th equaled 5. And I was just trying to see if they knew we were going to put it to the 1/8, and I completely forgot that I had just done an even root. So the answer is absolute value of x. And then this is some weird decimal. And then I get two answers because you get a positive and a negative answer. Okay, back to our problem. I bet a ton of you would have forgot that. Then you got two answers. 2x minus 1 equals 2.28. And 2x minus 1 equals negative 2.28. And honestly, from there, you should be able to solve it. I'm going to subtract 1, or sorry, add 1 and then divide by 2. I'm not going to finish it. I know that might be not be very satisfying, but we have so many problems to do for practice. I was mostly doing this one to see, would you know to use the reciprocal power, and would you remember that we did an even root? Oh, so easy to forget. Okay. So many topics, so little time. Next one I want you to do is, I'm going to start with $1,000. I'm going to end with $5,000. It was 3 years. Can you write the equation for that with exponentials involved? It starts at 1,000, it ends at 5,000, it happens over 3 years. Here's a start. Give it a shot. Snap in. This is important. Can't expect you to be perfect, but I can expect you to try. Now, I don't know what the rate is. You never told us the rate. That's the point. Did you remember to put a 1 plus r? Who figured that out? 1 plus r. Nice. And then it's 3 years, so the 3 goes here. And where does the 5,000 go? Where y is. Good. Now, take a second and solve it. I would divide by 1,000 on both sides. That's just going to be 5 then, and that's going to cancel. 1 plus r to the 3. Then I'm going to put both sides to the 1/3 power. And 5 to the 1/3 is 1.7. I'm going to round. 1.71, I guess. And this is 1 plus r. Take away 1. Rate is 0.71. You think that's 7%? 71%. And that's, if you think about it, you got to get 1,000 to grow into 5,000. You got to be multiplying by a pretty big number. The rate turned out to be 0.71, as in 71%. Okay. Then there was graphing. This, honestly, is a little too easy for a graph problem in honors. So I'm going to throw in a couple things to make it more realistic. A 4 up in front, and then there's going to be a few kids that think, oh, so you mean 12 to the x? No. You can't multiply the 4 and the 3 because the 3 is to a power. I'll make your life a little better by going like this, just to show you that 4 is separate. And then I want to put a -1 right there. Can you find me 3 points on this thing? I'll pause for a second. Will you find me 3 points on this graph? Hint, start with 1. 0 is a little tricky. Start with 1. When the numbers get too big, go the other way. Okay, next up, you may have found 3 points by now. Awesome. And if you graphed them, yay for you, but you need a how do I say that right? An asymptote. There we go. You need an asymptote. Do you know where it is? I bet a lot of people don't. I want to remind you that they usually look kind of like this. And the asymptote goes right through there at 0 unless it's been moved up or down. Was this moved up or down? It wasn't moved either way. Therefore, where's the asymptote? At 0. So the asymptote's still in that same spot. So then I just got to find 3 points. So I'm going to go stick 1 in. I put in 1 right here, and that's 3 to the 0 is 1. 1 times 4 is 4. A lot of people mess up that number. Next, I'm going to put in 2. 2 minus 1 is 1. 3 to the 1 is 3. 3 times 4 is 12. I put in 2, I got 12. Do you get if I keep going up, I'm going to get really, really big numbers? Okay, so 3 is not a great idea. It's going to be huge. So let's go to 0. And 0 is tricky, but you got to be able to handle it because you need 3 points. What is 3 to the negative 1? 1/3, very good. And then 4 times the 1/3 is 4/3, or 1.3, and I'd be fine with either one of those. 1.3 repeating technically. So 1/4 is like here. 212 is like way up there. And 0, 4/3 is like right there. And I'm getting the idea. This thing kind of runs like this. Arrows on both ends. Okay. There's a lot of topics. But graphing is on there at least once, maybe twice. So do you want more practice on graphing, or do you feel like that's enough? I need an opinion. 1 means I suck at graphing, and I'm scared of it. 5 means I'm perfect at graphing. I don't need to practice anymore. Are you at 5? I don't need to practice anymore? Or are you at a 1 where you're terrible at it? Raise your hand, or like hold it up so I can see it. All right. I'd say I'm at an average of probably about a 4, meaning most of you guys are in pretty good shape. So if you want to ask for more practice on this, you're going to have to tell me that. Maybe come up in the work time. All right, this one's not a graph it. It's a which way did it go? All right, was this exponential growth or exponential decay? Decay. It's an exponential decay graph. Now, would you agree that exponential decay graphs go down over time like that? And they have an asymptote right there also. Does that make sense to you so far? But has this one been moved up or down? It's been moved up 5, so that asymptote wouldn't be at 0 anymore, right? This whole graph, including the asymptote, would have moved up 5. But wait, one more thing. What would this do to the graph? Be specific. I know it's a reflect, but which kind of reflect? Vertical reflect. Can you in your head make this leap that it looks like that now? That's what the vertical flip does. Except it's also moved up 5. So it might be more like this when it's done. Okay. So many things to talk about, so little time. Next one. I think there's still a fair number of people that are not sure what fraction exponents really are. What's the fraction exponent for that? Don't say it, write it. And we shouldn't, it's either 2/3 or 3/2. Which one is it? 2/3 is correct. Okay. Well, why would you need to know that? Because what if the problem said that equaled 4? Could you solve it? Do it. I can do this one in my head. Square root of 4 is 2. To the third is 8. Cool. And wrong. Who can tell me why? I can see 3 people that got it. Look at it close. This is your test, and you just did this, and you just realized something feels wrong. Jaden Johns. It has 2 answers because you just did an even root on both sides. So that means this is an absolute value. So there's 2 answers, x equals 8 and x equals negative 8. Oh, it's going to be so easy to forget that. What if right before the test somebody told you, hey, don't forget about this? Would that improve the probability you'd get it right? Well, that person's not going to be me. It needs to be you. So maybe you should write yourself a little note to read right before the test. This is going to be on there. All right, here's another one. A to the 5th over a to the negative 2nd equals a to the 11th. Man, I wish those bases were the same, because if the bases were the same, I'd just set the exponents equal to each other, but the bases aren't the same. But they can be if you do this right. All right. Did you realize that this was an impossible question? Will that possibly ever happen on a test? Yes. You got to get ready from now, this test, until forever from now. There are answers that are 2 kinds of answers. One is extraneous answers. That means you solved it, you got an answer, and it just doesn't work. That's an extraneous kind. Then there's another kind that just the answer is that there's no answer. That's different. This is a no solution. There's no way to solve it. Yes?
Could you be 1? A be 1?
Ooh, maybe. 1 to the 5th is 1. 1 to the negative 2nd. 1 to the 11th is still 1. Actually, you might be right. There might be a solution of 1. Oh my gosh. That's really outside the box. Cool. But what I'd hope is if I just change this one little thing here, I'm going to make this a x right here. Then you could solve for x. There's not 1 anymore. That was a good one. Try solving this one. I'm not just wasting your time. There's things like this that you have to know. So I was thinking about writing on the wall, like up there, like Server's law of solving. One of them would be if you can factor it, you should. Our test doesn't have tons of factoring this time, okay? But there's generally, anytime the whole class gets stuck, there's usually a factoring kind of answer. Another one of my laws of solving is clear out the fractions. Do you get we have a fraction bar in this? Which means we have a fraction. Want to know how to clear out the fraction? Now, some of you did this a different way, but I'm going to show you this way. It'll work. Would you agree that if I multiply both sides, here and here, by an a to the negative 2nd, then this would cancel this? Does that make sense to you? Now, to me, that's better because there's no fraction anymore. And it's a to the 5th equals a to the, when they're like this, you add them. So it'd be x plus negative 2, aka x minus 2. Now, I know some of you did it a different way. I'll honor that. I'll go do it the other way. Let's just finish this, though. Would you agree x would have to be 7 to make that work? Okay. Now, a lot of you got 7 another way. I'll show you. If you add a to the 5th over a to the negative 2nd equals a to the x, you could have just said that and that. 5 minus negative 2 means like 5 plus 2. It'd be a to the 7th equals a to the x. So x equals 7. Either way, the answer is x equals 7. Okay. Whew, so many things to know. All right, your next one is back to just kind of normal exponents. Solve. Actually, no. Simplify. It's gross. But if you just do one thing at a time, one little like, oh, I'll make it a little better because I'll do this part. Like, if I were looking at it, I'd be going, is there any way to put the 3 and the A and the B together? No, I can't add those together. Is there any way to do something inside there? Nothing inside there. So then the only thing that's left is I got to do this power right here. I've been avoiding it, but... And then if I was going to do that, I would probably square everything. And then do the negative part. Because you can do the squared separate. Leaving this part alone. I'm going to square everything. 16. A to the 5 squared is like you multiply those, so that'd be 10. B to the 4th. But I haven't done the negative power yet. I better call it a -1 because just a negative doesn't mean anything up there. And that means all that stuff needs to go in the denominator. So I'm going to leave this red. And now all the blue stuff's going to go down here in the denominator. And it was to the -1 to just tell me, hey, I'm not happy up here. So it goes down to the bottom, and now it's happy. There's almost your answer. It's just that A to the 2nd over A to the 10th can be simplified down. And this one can be simplified down too. 3 over 16 can't be simplified anymore. There's A to the 8th on the bottom and B to the 4th on the top. Raise your hand if you got to the right answer. Cool. If you're not sure why that happened, you can ask me. I can try to explain it to you. All right. Next up. Can you set up this situation? I buy a $60,000 car. I drive it for 3 years, and it's gone down to be worth $25,000. What was the depreciation rate? You could set up an equation for it. Just to save time, just set it up. You don't have to even solve it. Can you set it up? All right, did you say that it was 60,000 to start with? You multiply by 1 plus the rate to the 3 years, and it's 25,000 at the end. Divide both sides by 60,000. That cancels. And I got 0.416, 1 plus r to the 3rd. Then I take it to the 1/3 power, and I got 0.7469 equals 1 plus r. Subtract 1 from both sides. We would round to 25%. Raise your hand if you got a 25% rate of decay. Cool. All right. Here's one that I was surprised people didn't know how to do. How would I start that one? Yes. Add 10. All of a sudden I'm at 30. Then what? Multiply by 2/3. Does that trigger that special thing? No, I didn't just take an even root. You can do cubic roots of negatives, so that this is not a problem. X plus 4 equals, and then from here, you just have a decimal and you'd have to subtract 4, no big deal. All right, it was just, did you know how to start? All right. Can you make those bases the same? We're almost done. I think this is the last problem. Did you realize that that 1/5 could be replaced with something? Or this 25 could be replaced with 1/5, but that's harder. Maybe it's not. Do you get if I could make it be a 1/5? Then they'd have the same base. And that'd be good. But it's 1/5. I kind of like this idea now. How do I get 25 to be a 1/5? Yes. Power of -2. Look at that. A fraction's actually a good thing on this problem. Now, could you have made this into a 25 to a power? Yeah, I could say it was 25 to the square root and flip 25 to the -2. So if you like that better, we can leave this 25 alone and then say this one's 25 to the -2 because that square roots it and flips it 1 over. And 25 is 25 to the 1, of course, right? Then I'd have 1 equals, ooh, all that. I have a suspicion. If we just solve from here, I think a lot of people are going to make a dumb little mistake. Go ahead, solve that one. See what you think the final answer is. And then they got the bases the same. They're both 25. So now it's just down to it. 1 equals all that. Solve it. Did you say 1 equals -2x plus 1? Good, I'm glad you didn't. If you did, you forgot -2x and multiply that out, -2. And then you just have to add 2 to both sides. All of a sudden it's 3 equals -2x. Divide both sides by -2. -3/2. Who had that one right? Okay, cool. You made it to the end. So, now, I normally try to make the homework, you got to admit, almost every homework so far I've made it shorter. Sometimes even on the Schoology quizzes, I've cut out a problem and you don't even know it. So I've been trying to keep them reasonable. This one, you really need to do them all. You need to be ready for all of those things. And this is one of your hardest tests you've ever had this year, which probably means one of your hardest math tests of your life. Not saying you're all going to bomb. I don't think so. I think a lot of you will rise to the occasion and get an A. But you need to do all the practice. And if there's anything you don't understand, you need to get help. So, without further ado, I am going to park myself and offer help up at the front. You should take advantage of that. That's all I got for you for today.